So what can we learn from a cohort study? Well, we know we can learn the relative risk of an exposure, and we can learn the relative risk of many exposures in a good cohort study for many outcomes. So relative risk we know because a cohort study, unlike case control or cross-sectional, gives us incidence data, and that's what we need to calculate relative risk. And so it's also what we need in order to understand causality. But there's something else that we can get from a cohort study, and that's attributable risk. And attributable risk tells us how much of the disease that's occurring in the person is attributable to that exposure. So as we know, multiple factors are related to the development of a particular disease, and attributable risk tells us how much of the risk of disease is caused by a particular exposure. So by understanding how much of the disease that occurs is attributable to an exposure, we can then understand how much of the disease can be eliminated if we eliminate the exposure. And so this is useful for prioritizing public health, money, and so on. So the attributable risk is just the risk difference. So it's the excess risk of disease in those who are exposed versus those who are unexposed. So it's just incidence in exposed minus incidence in unexposed. So as we've written it before, I sub E minus I sub U. So let's talk about an example. So let's go back to the concussion study that we just finished looking at, and if we want to calculate the attributable risk for each of these levels of exposure, so having different numbers of previous concussions, then this is how we do it. So we take the, we remember that it's the incidence in the exposed group minus the incidence in the unexposed. So for one concussion, the attributable risk is 0.96, because that's incidence in the exposed, minus 0.66, incidence in non-exposed, equals 0.30. So, and then you can look at this down here, and you can see that this difference, so here's the unexposed for each of these, so this is the attributable risk for having one concussion, and right here, this difference here is the difference between the number of incident concussions for the unexposed and the number of incident concussions for this level of exposure is the attributable risk of this level of exposure. So just see if you can figure out how to calculate the attributable risk for 2 concussions and for 3 or more concussions. And we'll just pause, or you can pause. So there's the answer. So what this means is that for those people who had 2 concussions previously, the over one of those concussions was due to the, more than one of the subsequent concussions that they experienced during the course of the study could be attributed to the 2 concussions that they had had prior to the onset of the study. And similarly, over 1.5 of the concussions that were experienced by the people who had had 3 or more concussions previously, it's a big mouthful of words here, could be attributed to their prior concussions. So as you can imagine, particularly looking over here, often attributable risk is presented as a proportion of the risk in the exposed group. So here's the formula. So you just take the difference in risk between the exposed and the unexposed and divide it by the exposed. And so if you look back over here, you can see why that's the case. So what you want to do is you're looking at, here's the attributable risk right here for this 2 concussions category, right? So this is the amount of risk that you get from this exposure level that's above and beyond that you would get if you were never exposed. So what we care about now is the proportion of this red area to the whole bar, and that's what this attributable risk proportion is. So let's calculate that for these 3 groups. So we're just going to take the same number that we used before, and then we're just going to divide it by the incidence in the exposed, which is the whole bar, and then we'll just take the proportion of the bar that's due to that exposure. So there we go. So it's 30%. So if you look back over here, 30% of the risk in the 1 exposure group can be attributed to that exposure. And so now you can try it for the other 2. Okay, so there's the answers, and also I put percent over here before, but it's obviously that's incorrect. So 0.3, it's not 0.3%, it's 30%. So so this is 30%, this is 64%, and this is 70%. And so you're just going to, attributable risk is sometimes reported in percents and probably usually, and then sometimes reported in raw numbers. So you'll just have to, interpret it the way you need to in the context. So you can also calculate attributable risk using the relative risk. Before we were using incidence, you can use the relative risk and calculate attributable risk proportion by taking relative risk in the exposed minus relative risk in unexposed over relative risk in the exposed. So it's the same pattern as the incidence, but now you're just using relative risk. And furthermore, relative risk in the unexposed, as we know, is always 1. So it's really relative risk in exposed minus 1 over relative risk in the exposed. So let's do it with some of these with the concussion example. So for 1 concussion, the relative risk in the exposed is right, where is it? 1.5. So 1.5. Relative risk in unexposed is 1, as it will always be, all over 1.5. And then we get 0.33, and probably due to rounding error, it's a little bit different from the attributable risk we calculated using incidence. But let's try the other ones. So you try to do them yourself. And there. So the numbers are pretty much the same, but it's useful to know how to calculate you need to know how to calculate attributable risk using incidence and relative risk.